and this is a project on photonic computing. Photonic computing is also known as optical computing. Photonic computers does its computations with photons and IR beams, infrared beams, as opposed to electronic-based computation that is done with our traditional computers we have today. There are two types of photonic computers. There's the pure optical computers and the electro-optical hybrids. What is electro-optical hybrids? It uses optical fibers and electronic parts to read and direct data from the processor light pulses and sends information instead of voltage packages. Uh, Processor changes from binary code to light pulses using lasers. Information is then detected and decoded electronically back into binary so the computation can be done like we do today. What are optical transistors? Transistors based of Febvre-Perot's interferometer. This means that there's a constructive interference yields, high intensity, which means there is light, and that is translated into 1 in our binary language. And there's destructive interference yields, which is close to 0 intensity, which is a 0 in our binary. Holographic memory can store data in the form of hologram into a crystal, within a crystal. A laser is split into a reference beam and a signal beam. A single beam goes through the logic gate and receives information. Then the two beams, the reference beam and the signal beam, meet up again, and the interference pattern creates a hologram into the crystal. This is a, a depiction of how this technology works. Optical fibers. These are the wires that are used in um, optical computing. They're they're small in size. They have low transmission loss. There's no interference for radio frequency, electronic components, or crosstalk. They're much safer. They're more secure, and they are more environmentally immune. This is a picture of a optical fiber or a rendering of it. And as you can see, they are really small, up to 245 micrometers. Uh, the, what are the benefits of optical computing? They're small in size. Um, they have a higher speed, low heating. They can be configured really easily. They're really good at scaling. They can be scaled really easily. Uh, More complex function can be done faster with the application of artificial intelligence. I can talk about that a little later. Less power consumption as well. What are the limits of it? Well, the optical fibers are a lot more wider than the electronic traces that are used in circuit boards today. So it will take more room. The crystals I just talked about are also bigger than the transistors we use. So again, it will take more room. Um, and there also is going to be a need for more software developments that can use this technology and implement it in the way we need it. There were a lot of things need to be done in order for optical computers to come alive. There still needs to be a lot of work done. For example, uh, Edmund Becquerel in 1839 uh, created a substance that electrical current can be detected uh, based on if there's an exposure to light or not. That's where the concept of the transistors came from, the optical transistors. There's also Charles Cow, who did a paper on optical fibers, and it was developed after that. Intel put together uh, uh, electronic components with the optical components to create a module that was really fast. And also, like I said, the AI component of optical computing. Um, in 2007, scientists created photonic computer microchips, which was 1,000 times faster than a human brain. So it clearly shows where this kind of technology would be great. These are my references.